I would like to remind you that submit your question in the question and answer tab. And also that this version of the webinar will be available at the World Potato Congress webinar website, sorry. Also, I would like to thank all the sponsors who are listed in this slide for support this initiative. Today, I will talk about work we done in Latin America about the implementation of an early warning system for sustainable preventive management of potato lay blight. I will talk about the importance of lay blight, introduction to the study we did in Latin America, about the Phytophthora infested monitoring that we did in the territories where we work. Also, we did some variety susceptibility evaluation, warning system validation, and also we work with our farmers about knowledge dissemination. As you know, potato is a major crop in Latin America, also around the world, and is the main food mainly in family farming. Potato lay blight can produce symptoms on leaves, stem, and also on tubers, and cause losses 100% sometimes when environmental conditions are favorable. This is a disease that the expression of the disease depends on the environmental condition. And also, today lay blight is considered a re-emerging disease due to pathogen variability, climate instability that favor presence and dispersion with a high incidence and severity. Environmental conditions that favor lay blight usually are temperature between 7 and 25 degrees Celsius, relative humidity over 100%, and rain and leaf wetness. Leaf wetness is very important because favor the sporulation of this pathogen. When conditions are favored, the pathogen sporulate and produce the sporangia. And this sporangia can be carried out by rain and wind to other crop and to other potato plants. Lay blight, or tizón, how you say in Spanish, is a problem of global importance and difficult to manage. That's why networks have been formed on different continents to work together to share this information and advance practical and sustainable solutions. That's, for example, the case of Blight. In Europe, this group is working in lay blight long ago, they started, and also in the United States. Followed that idea in 2014, under the umbrella of the Latin American Potato Association, Tizón Latino was formed to join efforts and resources for the study of this disease. At that time, we noticed that there were different researchers and working in this problem. And then you say, why do not work together? And the idea was advance in solving this problem, especially in small-scale agriculture. That is the main production system in our continent. And then we need funding. And then we thought that we can present a project. And that in 2017, we presented a project to Fontagro. Fontagro is a cooperation mechanism to promote science, development, and innovation in food and agriculture for Latin America and Caribbean. We get that grant, and the project was focused in early warning for management of potato leaf blight. And the main objective was to constitute a platform of specialists in potato leaf blight with the aim to develop and implement this early warning system as a tool to support productive system of family farming in participating countries according to the technology that was available, enabling reduction of losses caused by leaf blight. We work with Chile as a leader, and together with Argentina, Ecuador, and Panama. What we did in this project, first we did some monitoring of the causing agents, Phytophthora infestan. To do that, we use this collection using this FDA card. This system works when you print the symptoms of the lesions on this card. And here you can see a video where teach you how to do it if you are interested in learn how to use these FTA cards. And the print of the lesion is identified in this card, the place where it is, the variety, and other information. And these cards are sent to a laboratory to identify. We use population genotyping using 12 microsatellite markers to define the molecular linkage group. We use the methodology described by Cook and Lees in 2004. All this work was done by Dr. Florencia Lucas in INTA, Argentina. We were able to get 528 isolates from Argentina, Chile, Ecuador, and Panama. And also, we were able to get other isolates from Brazil, Costa Rica, Peru, and Uruguay. Here you can see a graph where you can see the population, the distribution of the population. This is a Chile population that is, in general, is very homogeneous. The same in Argentina. This is from Ecuador. And in Panama was a little bit more variable. There was some were similar to Ecuadorian, and other more similar to the one in Chile and Argentina. Here you can see a map, how the population was distributed. And in Argentina and Chile, and also in Panama, the main genotype was EU2A1. That was an isolate that was described at the end of 1990 to thousands in Europe, in England, and also in Netherlands. And how this isolate get into Latin America, we need to talk about that. Mainly, it could be using seed, importing seed from Europe. But in Ecuador, and also the isolate from Peru, were mainly EC1. This is an endemic Phytophthora infestan. You know that Phytophthora infestan is a native from Latin America. And this map is very interesting because in some way tell us how genotypes are moving around the world. It will be very interesting also to know what's happening in other countries. And also to follow this monitoring to see how the population is changing, and take advanced how to do. what to do if we have problems. Also, we did some varietal susceptibility evaluation using the main commercial crop in each country. We did in two ways, using the leaf disc laboratory and field, and also a field plot. Here you can see some picture how we did in a leaf disc and also in a field. And then after that, we evaluate the relative susceptibility of these cultivars. Interesting, I want to share with you this information. This is the evaluation of some native varieties from Chile, from the Chiloé island, Solanum tuberosum, the Chilotanum group. And how you can see in this graph, this is the foliage damage on time. And most of these varieties are very susceptible to lay blight and are very susceptible in an area also where conditions are very favorable for the disease. Some of them, for example, Murta, show very good resistance to this disease. And after this evaluation, we rank the varieties according to the susceptibility index developed by Forbes et al. In 2014, 1 to 9, where 1 is more is less susceptible, and 9 is more less susceptible 1 and more susceptible 9. And here you can see that, for example, very susceptible, these Biscocha, Bruja, Murta, Cabrita, they are native varieties from Chiloé. And also, for example, Cornado, that is a commercial variety, is very resistant, Murta. And Patagonia also show very good resistant. This is a variety developed by INIA Chile. To the warning system evaluation, we use two different systems. One based on real-time Connect weather station network information. That information was available in Chile and Argentina. In Chile, we worked long ago with this system that is in the webpage tison.inia.cl. And in Argentina, they work with this system, PhytoAlert, developed by INTA. But in Ecuador and Panama, how this information was not available, we use a system developed by the International Potato Center that is based in this disk. I will tell you ahead how this works. For this early warning system that we use in Chile, this system is available in the southern part of the country, covering the main potato producing area. It uses 54 stations of the INIA meteorological network. This is in real-time information. And alert information is sent to the user through the platform. Also, emails and text messages to the phone. Today we have 6,700 registered users in the system who receive the information when the conditions are favorable for the disease. How the system look, for example, during the season, if the conditions are good, you can see different colors in the map. Red, orange, yellow, and green. And red means very good conditions, orange, good conditions, yellow, medium condition, and green, no condition for late blight development. And the message in email is this form. In the weather station where you register, the conditions are red, for example. And also in the phone, you receive these kind of messages. Also, it tells you where you are registered, the condition are yellow or orange or red, and also few message what you need to do. In Chile, the system is available since 2010. And this also allows us to focus in different territories and how the condition historically are for lay blight. For example, here you can see that are the seasons and these are the months. And in this territory, for example, green days are predominant. However, in this other area, red days are predominant. And that means that this area is very favorable for the disease. However, this is less favorable. And then the recommendations are different. For example, in this area, resistant varieties are very important. And this is the system that we use in Ecuador and Panama. This is a layer of different discs. The lower disc show a color, red, yellow, or orange, and that indicate what you need to do depend on the susceptibility of variety that are you using. Red one are very susceptible, medium susceptibility, and green more resistant varieties. And the blue disc is related to the environmental condition. Observation that the farmers do where they are. If it rain or fog, for example, in the last 8 days. Here are the different questions that ask you how the condition has been in the last 8 days. And then you move this disc to this yellow arrow according to the answer you have. And this, the next disc is the yellow one, is related to the fungicide. If you're doing application in the last 7, 8 to 10, or 11 days, that means how with fungicide the plant is protected. And also different question, and you move the disc according to what the answer you have. And the central disc, this purple one, is the sum of these numbers that are here and indicate the risk that you have. If the sum of this is 7 or more, you need to spray systemic fungicide. If the sum is 4, 6, 5, you need to spray preventive fungicide. But this is the lower, you don't need to spray. And this is the information that the farmers use to take decisions. The project working model is in this graph. We focus in 2 steps. The first one was the warning system validation in the territories where we decide to work, and also understanding and adoption of the innovation. To the validation of the system, we use experimental plots in each country. In total, we work with 29 experimental plots since 2019 to 2023. We analyzed the result with the farmers. We did an evaluation of the impact of the system and also a publication and dissemination material. In the second step, to understand the adoption of this innovation, we did a survey as a baseline with the farmers, asking how they manage and how they know or what they know about the disease. And then at the end of the project, we did another survey. This allows us to evaluate the impact of the system. And to teach the farmer about this warning system, we did field days, seminar, we developed a web platform, and also a workshop. The workshop were focused in control strategies, best agricultural practice, and safe use of pesticide. This is very important because most of the farmers that are working in small farming in Latin America are women. And also integrate pest management. Sorry. Here, two graphs about the farmer's baseline. We ask how they control lay blight. This is the number of percentage of persons we survey. And most of them in each of the country said that fungicide was the main way to control lay blight. And few of them, they use other cultural management. And also we asked about the number of spray they use to control the disease. Panama, 20, Ecuador, 15, Argentina, 17. In generally scheduled application. And in Chile, we work in the Chiloé island. Farmers say that they only spray 3 times. However, when we ask how they decide to spray, usually they spray when they see the problem and the problem is already big. And then how we validate this system? With experimental plot, we use the split plot designed with 4 repetitions. Main plot, we use information for variety of different susceptibility. We want to know if the system works according to the susceptibility of the variety. And as a subplot, we use 3 treatments and treat control, no fungicide. Fungicide application on a calendar schedule, 3 days or 7 days, according to the country, how the farmers do it usually. And fungicide application according to the alert system that was evaluated in each country. Chile and Argentina, the system that we had, and in Ecuador and Panama, they use the disc. And also, we record the number of application according to the system, the cost of application, and also we calculate the environmental impact quotient. This index, for this index, we use the information available in the Cornell University platform. It's a calculator. This is the link to this calculator. And here you can put the fungicide and the doses that you're using, and it gives you the number and the impacts that this application is doing in the environment. The cost of the application was estimated using the value of the products in local market. Usually we use the equivalent of the US dollars. This is an example of the experimental plot. In every of these square, you can see different varieties, variety 1, 5, 4, 3, 6, 2. There are different varieties that we know either were resistant or not. And in each of these variety, we evaluate the application with calendar strategy, no applications, no spray, and application according to alert. And here you can see this is an aerial picture of the experimental plot. There are different colors and damage in each of the in this experimental plot. Here you can see that, for example, in this variety 1, the plot that have no spray have no symptoms. This is a resistant variety. However, variety number 5, the control have a big damage of late blight. You can see a very brown in this one. However, the calendar application and the application according to the warning system, they have no symptoms or few symptoms. The variety number 2, for example, you can see that the control have symptom, but lower symptom than this variety number 5. But also the calendar and the alert are very similar. This is the graph that sum the result. This is the foliage damage for each of the treatment. This is the untreated control for each variety. And then you can see the susceptibility of these varieties. And this is the application with calendar and with alert in each of these one. And most of them, there was no significant difference between the calendar and the alert in the symptomatology that you can see. However, in the more susceptible varieties, you can see a little bit of symptoms using these alert symptoms. However, was a big difference with the untreated control. Here you can see the warning system evaluation by season. This is results from Chile, and how also in the different territories are very variable according to the season. Yeah, this is 2018-19, and here 2022-23, for example. And in 2018-19, this is in Chile. You can see that no application had very big damage, but calendar and alert few damage. But also, it's interesting that when we evaluate in areas where it's few risk for the disease, in the no treat we have no symptoms, and also we have no symptoms in the calendar and the alert. Yeah, and that is very important because it tells you that maybe in some seasons it's not necessary to do application. When we evaluate the yield in each of these experimental plot, here, for example, you can see that where we have good conditions for late blight, there was difference between no spray and calendar and alert. But all the season, we had no difference between application according to calendar or application according to the warning system. When we evaluate the total of the experimental plot in each of the countries, this is the graph showing the calendar application and the alert system in every country, and evaluating the cost, the environmental impacts index, and the number of spray. And as a result, we were able to reduce the amount of application in 53.5%. The environmental impact quotient in 56%, and the cost of fungicide application in 60%. And that is very interesting because under different conditions, like Panama or Ecuador, where you have very good conditions usually for late blight, also the warning system work very well. For knowledge dissemination, here you can see different pictures, the activities that we did with farmers. Monitoring of the pathogen, teach them how the weather station work, experimental plot for resistant varieties, seminars. We have also the cooperation from the International Potato Center for that. In Argentina, also talking on seminars with farmers, field days, and very important, we teach them in a practical way how to do an efficient fungicide application and in a safe way. That is very important. We work with them and in a workshop in a practical way. This is the number of activities that we did. The main activities were focusing safe use of pesticide, integrate management, and how to use and interpret a warning system. We work with 2,761 persons. 41.6% of them were women. Mainly in a very small farming that was important. When we evaluate the survey that we did, comparing year 1 and year 4, when we ask about the if they know about the condition that favor the disease, we notice an increase in the knowledge. Usually they associate rain with disease, but maybe the more important was the leaf wetness. Yeah, and then say when leaves are wet, conditions for lay blight are good. Beneficiaries with knowledge of source of infection. Usually they associate that lay blight coming in with the rain and the wind. But what were the source? For example, potato waste or volunteer potatoes that were very close. And then we teach them how to do best agricultural practice, hygienic, yeah, clean everything, eliminate a source of infection, eliminate the waste potatoes or the volunteer potatoes are very important. Also with the number of control management. They use some of them, they understand about resistant variety and they understand about fungicide. But we teach them that there are other ways also. We need to manage the potatoes to avoid that the leaf were wet a long time and clean, eliminate the source of disease and others. And then they learn more way to manage the crop. Most of them also, they were able to use the fungicide in the right way and when was necessary. This is the beneficiaries who have been trained in best agricultural practice. All of them increased in that way. And beneficiaries using personal protective equipment. We noticed at first that the farmers, they say that yes, we use protective equipment to apply fungicide. However, usually they associate the use of mask. This is the one similar to the COVID ones. But we tell them that was not enough and you need to use another equipment to protect yourself. And the beneficiaries that at final of the project were using the early warning system to take decisions increased. In Chile, from 20 to 59. In Ecuador, they increased to 82%, 0 to 82%. and in Panama to 27% of the beneficiaries. At the end of the project, they were using the system. And this is important because to use a new technology and take decision in this technology sometimes is very difficult for the farmers because they need to know how it works, they need to try the system. And if they see that it's good for them and it's easy to use, they adopt it. But if not, it is more difficult or is risky for them, they prefer to continue doing what they are doing. But we believe that in Panama, if they use 27% of the farmer take decisions with one system, is a success. And this is also the number of stray per season. In Ecuador and Panama, we decrease the number of spray. And in Chile, because in the island, it's a good condition for lake blight. The farmers, some of them increase the amount of spray, but in the right way and in the right moment, and they do not have lake blight at the end. As a comment, the result for validation of this early warning system in the project showed that the chemical control strategy with warning-based application were able to control lake blight with similar level of damage to the fixed schedule treatment without affecting yield, especially in moderate resistant and resistant varieties. When they use a susceptible variety in an area that is very favorable for the disease, we need to do more integrated management. Lake blight control strategy using the early warning reduce the number of application, the environmental impact, and also the cost of the fungicide, over 50%. And the varietal resistance evaluation show also that there is a great variability in the response of the cultivar evaluation. This information is the great relevance for integrate management package. And again, in areas where you have a very good condition for lake blight, resistant variety should be used. And the warning system contribute directly to the economy and health of farmer and their family. We reduce the amount of application and also using in the right way. And that is good for farmers and cost and also for health. The dissemination of knowledge was carried out with the entire production chain. We work with advisors, we work with the farmers, we work with decision makers. And then that everyone know how to do and how to do it. And that's it's the big impact. The use of information based on early warning help farmers to carry out chemical control in a timely and efficient manner, and only when it's necessary. I think that is very important because some farmers avoid the risk and they prefer to apply in a scheduled way. But using this warning system, if they know the system or try the system, they can avoid some applications. But for this also, we need to work in a training. Training the farmers and all the production chain in integrated management, best agricultural practice, promote climate change adaptation, and also mitigate for sustainable intensification of potato production. We need to work in a sustainable way. This is the group of work. This is Florencia Luca from INTA Argentina, Cristina Tello for INIA Ecuador, Rodrigo Morales and Anulfo Gutierrez from IVIAP in Panama, Also, Rodrigo Bravo from Chile. He worked in the Agrometeorological Network. And also Juan Quintana and Maria Carolina, that they work in the National Meteorological Institute in Chile. More information about the project is in the Frontagro webpage under this link. And for this project also, we developed this webpage that is called, it's in Spanish, and it's called enfermedadespapa.inia.cl Frontagro. In here, you can find information, technical information about lake blight developed by the project. There are videos. This is a video of what we did in the project and the result that we have. And also integrate management of lake blight and how to use the different warning system, and also publication and podcasts and information about this disease. What next? I believe it's important to continue monitoring for lake blight in Latin America and every country. We need to detect the population changing because it changes very rapidly. And also, Phytophthora infested move very fast. And there are different characteristics, resistant to fungicide. And then it's important to detect this changing very early to take measure to avoid big problems. Emphasize the development of varietal resistance. I think varietal resistance is very important to complement this system and also the management of lake blight. Expand the use of early warning system for rational and timely use of pesticide, and then applying only what's necessary. I think it's a very good system, and it can be implemented in other countries. And also think about integrated crop management. In the last meeting in the European Potato Association, they talk about that we need to work in a crop management and avoid diseases in general, working with the crop, trying to that they have a healthy crop to avoid diseases and decrease the amount of fungicide use. And very, very important, share information and knowledge on this sanitary problem and others, expanding cooperation network. I think these potato diseases are very important and produce a lot of losses in this crop. And I think we need to work together and complement the knowledge that everyone has. And that's it. Thank you very much for participating in this webinar. If you have questions, please write it in the question and answer tab. And also remind you that this webinar will be available at the World Potato Congress website. Thank you very much. Here I have some questions. Question from Babita. Intocast say is a model for lake blight prediction and using medium in India. Oh, good. I would like to know how it's work if you try this system. Here also, how many spray of fungicide is used in this season. It will depend of the country. At first, in Panama, for example, they use 20 spray per season. And with the system, we were able to reduce to 60% depend of the variety. When you complement with a resistant variety, the number of spray is reduced. But with susceptible variety, we get to 15 or less. In general, you reduce 50% the amount of spray. Thank you for the comment. I don't see more ask questions. Okay, if you do not have more questions, thank you very much for participating in this webinar.